Disproportionation reaction, a redox reaction which has been discussed by most of the students over the years. Hi, I'm Miss Joyce, the chemistry teacher from A Scorers Ace Chemistry. Now in this video, I'd like to discuss with you about the disproportionation reaction, which is actually a concept under the chapter on redox reaction. However, this concept is actually not found in the current O-level syllabus, but it has been appearing in the O-level exam a few times since the year 2011, which started to appear in that paper. And during that time when this question was being asked in the MCQ section, most of the students were were pretty surprised by these questions because they have no idea about what disproportionation is all about. Alright, so today I'm going to share with you about the concepts on disproportionation to give you a clearer insight in this reaction. Okay, now first of all, disproportionation is actually a reaction, or in fact it's a redox reaction, whereby the same element undergoes both the oxidation and the reduction. Now this is pretty unusual because the usual redox reaction has each element to either undergo reduction or oxidation. So in a disproportionation, it's actually referring to just one element, the same element, that can undergo both the reduction and oxidation at the same time. Alright, so in order to do these questions in the quickest way, especially when the MCQ question is being set or given in a time frame of 1.5 minutes per question, how is the student going to handle these questions when they need to how is the student going to handle the questions in order to find out the answer in the quickest way? Alright, so first of all, it's good to know that in a disproportionation reaction, only certain elements will disproportionate. For example, the transitional matter and also the non-matter such as the sulfur, chlorine, nitrogen, phosphorus. Alright, so if you were to look at the options given in these questions, first of all, you can identify what are the type of elements that can disproportionate. Alright, so if you look at the option A, B, C, and D, you can see that copper, alright, is a transitional matter. Chlorine in the option B, alright, is actually a non-matter that can also disproportionate. And in option C, we have iron, that's a transitional matter, and the option D, we have lead, Pb, is also a transitional matter. Now the next thing is to understand that since a disproportionation reaction refers to an element that can undergo, or in fact the same element that undergoes both the reduction and oxidation at the same time, it means that in an equation, after the reaction, there must have the same element that will appear twice in two different products in the reaction. So if you were to look at the option B, alright, if you look at option B, you can see that chlorine element exists in both products, that is the sodium chloride and the sodium chlorate compound. Alright, so this tells us that the answer B is very likely to be a disproportionation reaction because you have a chlorine element that undergoes reduction and oxidation at the same time to provide two different types of products with chlorine having a different oxidation number. Okay, so to look at it in details, we can see that the chlorine element has an oxidation number of 0, alright, in the reaction B. Now, after the disproportionation reaction, the chlorine in sodium chloride has a charge of a -1. Okay, so this NaCl for chlorine, it has a charge of a -1. Now, what about the chlorine in the NaOCl? How do we calculate the oxidation number of this chlorine in this sodium chlorate? So you can see that since sodium is a group 1 metal, it has a charge of a +1, and then oxygen is a group 6 element, which has a charge of a -2, then this means that the chlorine will have a charge of the +1 in this compound. So as a result, you can see that the chlorine has undergone and oxidation, whereby the oxidation number increases from 0 to positive 1 in the sodium chlorate, and it has also undergone a reduction, whereby the oxidation number decreases from 0 to negative 1 in the sodium chloride. Okay, so that's why B is the answer for this question. So in order to solve this question within 1.5 minutes, it's very important to understand the background of the disproportionation that is only applicable to certain type of elements. So in this way, you wouldn't need to check on the oxidation number for all the different elements asked in these questions. Now if you do that, it's going to be very time consuming, and that definitely take more than 1.5 minutes. Alright, so I hope that this will give you a good understanding in solving the questions on disproportionation. Okay, thank you. See you again.